Hey, children.
Time for section 5.2.
This is where the proofs get fantastically real and outrageously fun.
Okay, we are proving trigonometric identities. We've got some general proof strategies for you throughout the sections, and we've also, they basically take practice.
They take a lot of practice, and you're probably not going to like them a whole lot while you're learning how to do a proof. Now, before you have a big panic attack, stage 5 issues, this is not a geometry proof.
No, it's not. It's not at all like a geometry proof where you had to have statements and reasons and stuff like that.
But it is a proof that one side is equal to another.
Right. So what we do, let's look at example 1.
Hey, let's do that.
We're proving the algebraic identity. And incidentally, someone pointed out to me today about 5.1 that it's really just algebra in disguise. We really didn't do anything trigonometry related at all, except for that's how the identities come about.
That is correct.
So we're gonna prove an algebraic identity. We could put sines or cosines or whatever in here.
Right.
And do the same basic thing. We're basically just using algebra on all of these.
Right.
Okay, so what we do when we do a proof, and I happen to have quite a bit of practice at proofs.
Proofs are really fun. In my humble opinion, IMHO.
I will say that proofs are fun when you know how to do them. They're not so much when you don't.
Okay, when you say it like that, that's right. Okay.
Just like all math. It's
just
fun
like
when you know how to do it, but not so much when you don't. So what we do whenever we're proving an identity is they're telling us the answer. That's how you need to think of this. But we are not going to put equals 2 here.
No.
We're going to put some simplified version of this left side, and we're going to work with that until at the end we end up with equals 2.
Right.
And the work in between is really what our answer is. We don't actually have an answer that we box.
No.
So let's take this and look at it. We need to recognize here whether it's x's or if it was a sine squared x or whatever, that I would say let's factor these two into x plus 1 and x minus 1 because we're going to have something cancel out.
I agree with that 100%.
So both of these end up being x plus 1, x minus 1. But it's also very important that you show all your work. Someone, not necessarily us, because we know exactly how these proofs are supposed to work most of the time, but somebody who's in a math class of equivalent level, like your classmate, should be able to follow your proof and not be like, I don't get how you got from here to here.
They should be able to easily go from step to step to step to step. Now notice right here that Mrs. Stevenson, as she was writing, did nothing with the 2 at all. She worked only that left-hand side of the equation.
That's our answer that we're trying to get to, but we're not going to mess with it. That's just our goal to keep in mind. And it's helpful because we know a lot of things should cancel out.
Right.
So to end up with that too. So here I cancel the x minus 1s, the x plus 1s.
Looky there. That's pretty amazing.
For my next step, this fraction just has x.
For your next step? That's like a magician.
Exactly.
And now watch
minus,
as we make the x's disappear.
Remember, if it's a minus sign, that this needs to be in parentheses because we actually have to distribute this negative, which is good because otherwise we won't end up with what we want. So minus x plus 1. So we cancel the x's. X minus x is 0. 1 plus 1 is 2. So that's what we were trying to get to. That's our end step.
Right.
The stuff in the middle is the work. And notice how because you're studying math, you should reasonably be able to look back at this and say, I can see how we got to each step.
That is correct.
We didn't skip anything.
No.
Now, when you're in college and doing proofs, different professors tell you to do different things at the end of the proof to kind of be like, hey, I'm done with the proof. So here's what I like to do. Because one of my professors said, put a box. Okay, so we have a box. But I think that we should do something a little bit nicer than just a box. I think we should put a smiley face in a box.
A Minecraft?
A Minecraft smiley face in a box. So that says, hey, we're done with the proof. It does not have to be pink. It can be whatever color you're writing in.
Okay.
Okay, so on the next in your notes, you have these general proof strategies 1 here. And basically this is just telling you exactly how to do a proof. Begin with the expression on one side of the identity. So we started with the left side. Mm-hmm. It ends with the other side. So it ended with a 2. And in between is a sequence of expressions that you can easily see how they're equivalent statements.
Right. And there was no cross the equal sign manipulation.
Right. We didn't
here.
treat this as an equation. We didn't try to cross multiply because that's not allowed.
That is correct, 100% correct. So don't do it, and you'll be really tempted to.
Yes.
Okay, let's look at another one. Okay, so let's prove a trig identity now.
Now, it will be helpful for you to have your unit circle card handy where you wrote down the identities because we are going to use those pretty heavily.
Yes.
So you can start from either side, but I've worked all the problems in this section, and so I happen to know that you can start off with the left side and do just fine.
I like to start off with the left side too, usually, but sometimes I like to start off with the right side.
Yeah, sometimes the right side just looks more complicated and stuff. But I
would agree with
you
that.
can start with the left side and get there somehow on all of these. I have checked. Okay, so we start with tangent x plus cotangent x. We're trying to get to secant and cosecant.
Right.
We have for our identities.
I'm thinking, this is what I'm thinking. We start off with addition, we end up with multiplication, so somehow we're going to have to combine tangent and cotangent.
Right. And that would be easier if maybe they were fractions.
Yes, so let's convert away to fraction form of both of these puppies.
And you can go one of two ways. We could take like cotangent and change it to 1 over tangent, but I think it'd be more helpful to change the sine and cosine.
I do too. Let's do that.
So we're going to change tangent x to sine over cosine because that's a quotient identity.
And we're trying to
combine these into something else.
I think a fraction form here is ideal.
So cotangent is cosine over sine. And then now we've got two fractions. Let's do a little common denominator situation.
It's good plan.
So the common denominator here would be cosine x sine x.
Right.
You need to get used to the idea of these common denominators. I think in some ways that they're easier. So we need to finish up our numerators here. This had cosine, it needs a sine, so we multiply the top here by sine x to get our common denominator.
Sine squared.
So that gives us sine squared. On this one, we have a sine x, but we need to get a cosine x, so we multiply by cosine x.
Cosine squared. Oh,
that's
man.
Convenient.
Hey, looky there. Sine squared plus cosine squared.
And this is an identity that a lot of times just gets forgotten, but it's like the coolest identity. Sine squared plus cosine squared.
It's so handy because a lot of times you want to clean something up. If you can get to cosine squared plus sine squared, that'll do it because it's a 1.
Yeah. Now, we have 1 over cosine x sine x. We want secant x cosecant x. It may help you to think of this first, and you wouldn't necessarily have to do this step, but you might think of this first like 1 over cosine x times 1 over sine x.
Yeah, that's a good plan.
We can do that because it's a 1 on top.
Right, because 1 times 1 is 1.
And then cosine x times sine x is cosine x sine x.
And so now you should see right off the bat, because this is not a new identity here.
Right, 1 over cosine x is secant x. 1 over sine x is cosecant x.
Yes. Brilliant.
So
brilliantly done.
We got what we wanted. And sometimes you might find yourself like you're working through a proof and you're like, I just don't know where else to go. Like if we got here and we're like, I don't know where else to go. I don't know how else to simplify it. Well, remember to look back at what you're trying to get.
Right.
That's what we were trying to get.
And don't forget to add Minecraft, dude.
Yeah, Minecraft smiley face.
Yeah. Oh, that says match.
It does. So.
Oh boy.
One thing.
So we could mess up on this, is what you're saying.
We could. Well, it says match and then confirm with a proof. Why not just like start simplifying and then see which one you can work towards?
All right, I can do that. That sounds good.
Incidentally, though, we didn't actually talk about this in 5.1. You can use your graphing calculator, if you're allowed to check to see if two things are identities. And confirming that something is an identity just means that they actually do equal each other.
So I could graph the left-hand side and then graph the right-hand side, and they should be the exact same graph.
Right. So we could now graph this that we're starting off with and this one or this one. Right. Or you could graph all three at once and just pay attention to which two are the same.
Okay.
And then you would work out the proof. But
that's a good plan.
I happen to know which one it equals.
Oh, and you have to show all the steps.
Yeah, but we'll leave you in suspense, and let's see what we work toward.
A good deal.
Okay.
Speaking of which, I found my calculator.
Nice.
Yeah.
You were really worried about that.
Yeah, I was.
So here's our left side of our proof. what we started with.
Right, okay. And I want to get a common denominator.
I
Can we
want to
do
get
that?
a common denominator
Okay.
too. It's the way to go. So we need our common denominator to have secant x minus 1 times secant x plus
I feel
1.
like that's going to end up being something.
It will. It will. Good eye. Good eye. So, but first to finish this off,
Okay.
this fraction, this first one needs secant x plus 1.
Right.
The second fraction needs secant x minus 1.
Right.
It's a plus sign in between, which is
So
convenient.
plus is good because that means we don't have to insert any sort of bracket item thing.
Right. So now we need to see what we can do, like 1 and minus 1.
So we just have 2 secant x.
Yes,
on
because
the
there's
top.
a secant x and another secant x, so there's 2 secant x's. Yeah?
Yeah.
Okay.
Yeah.
Sometimes it's good to FOIL and sometimes it's not good to FOIL. And basically, if you can FOIL and end up with an identity, that's great.
Yeah, even better.
Yeah, but if you would FOIL and not end up, like if this had a different trig function in it, it's probably not going to work out
Probably
well.
not, but sometimes you still have to do that anyway to get something else to trig function up.
Right.
Yeah, but in this particular case, also recognize you got a difference of,
2 cubes.
well, you got the
cubes.
the difference of squares.
Difference
is
of
what it's going to be
squares.
because you've got the binomials on the bottom are the exact same except for the sign in the middle, which means you can square the first term, square the last term, and put a minus sign in there. So you shouldn't have to FOIL.
Right.
And
It
you
should
need
be
to
a
get
flaw,
Yeah, you need to get where you can flaw.
which is first and last,
Right.
without the outer and
Right.
inner.
You've got to get where you can recognize that and not waste time on the oil.
Absolutely.
Yeah.
Now,
Okay.
to continue on from here,
Get your handy dandy circle cards out because I'm feeling like secant squared x minus 1 is something.
like an identity.
Yeah, I'm thinking like
Well, if we
my big
subtract
toe's
the 1
itching.
on your second identity in the Pythagorean identity section, if you subtract a 1 over, so that makes it secant squared theta minus 1.
Maybe we could write
it
down what the one you're
equals-
working from. Tan squared plus 1 equals secant squared. Yeah. Yeah, there you go.
So
Okay.
we have to basically recognize that if I subtract 1 from both
Right.
sides,
There you go.
I-
There you go.
I get
yes.
this.
Yes.
And that
so
means that-
tan squared right there.
right.
Okay. I knew it. I knew it was something.
Yeah. Okay, now we if we can cancel stuff out and end up with a secant on bottom, it looks like the second one.
Right.
But there's a 2, so that's kind of like the first one.
Yeah. I'm thinking in 1 over tan squared, isn't that?
Couldn't we pull that up and make that cotangent
Yeah. So
squared?
can we say 2 secant 2? Yes. Okay. Secant x.
So it must be, since we have a cotangent, we need a cotangent, but then we don't need 2 of them, basically. We've got a squared. So what if we say, all right, 2 cotangent x, change the second cotangent to cosine x over sine x, and then change secant to 1 over.
Oh, that's good thinking. I
Cosine.
like it because the cosines cancel out and you have 1 over secant, which is cosecant, which is choice 1.
Right.
I love these. Gee willikers.
So 1 over sine x becomes cosecant.
Man,
So that's
how
it.
can you not enjoy these trigonometric identical
Well, I can
proofs?
see. I don't know why I circled that. That's not an answer.
That is.
We do our little
yeah,
proofy
get
thing.
your mind.
Although it's kind of an answer on this one. We would pick
Minecraft.
option number 1.
Yeah.
But I can see how it would be frustrating whenever you first start off. Like, we've got years and years of practice. Some of us more than others, as far as the years and years of practice goes.
I don't know why you would emphasize that and look at me at the same time. What are you saying?
You're the only person here for me to look at.
Okay.
Okay?
Yeah.
All right, so, and we've got some more proof strategies here in this area.
Some of us with more wisdom are excellent at these, by the way.
Begin with the more complicated expression, work towards the less complicated expression. So that means sometimes if you want to start on the right side, if it seems like if you can tell something to do on the right side, do it. Number 2, if no other move suggests itself, convert the entire expression to one involving sines and cosines. That's kind of what we did.
That's what we did at
here.
the very end.
We changed to some sines and cosines so that we could work stuff out. And then last, combine fractions with a common denominator
Right.
is a very good way to go.
I agree.
Code word real quick.
Code word.
Oh,
Pick the ink. Pick the ink. Code word.
I look at the color.
Code word. Code. What? What is
Like maraschino cherries. Just
on to the proofs.
okay. So prove the identity. We're gonna start with one side and get to the other, and we got a little hint here: setting up difference of squares.
Whoa! What's this hint business?
Just hinting, hint.
All right.
Okay, so the way we're gonna have to do this is actually, I'm gonna go ahead and rewrite this. Because since this has 1 minus sine t on bottom, and we're trying to get 1 plus sine t on top, we're gonna have to
I smell a 1 plus sine t somewhere.
Yeah, we're gonna have to get an identity basically, and so to do that, we're gonna multiply the top and the bottom by 1 plus sine t.
Now, here's why this trick works. It works because 1 plus sine t divided by 1 plus sine t is 1.
And you're allowed to multiply things by
you can
1.
Yes,
Doesn't
multiplying,
change 'em.
that is right. That is right. It's one of those old facts of algebra. We just picked a really funky looking one.
Yeah, so this is a useful trick to have in your trig function tool belt.
This is a good one.
Now, on the bottom here, if we multiply these together, it's first and last because it's difference of squares.
So 1 minus sine squared.
Hey, that's an identity.
Mm-hmm.
So let's leave. Oh, that's
Switch
not,
colors. Danger.
cosine t 1.
Yeah,
plus.
don't do that yet.
Don't distribute.
Don't distribute
until
yet.
you have to.
Right.
1 minus sine squared t. If you look at your Pythagorean identities, if we mess with
Sine squared plus cosine squared. Mess with that guy.
We want to subtract sine squared over. So 1 minus sine squared equals cosine squared.
I like it already.
T.
Look, that's a T. That's a T, not theta. That is one ugly T. Can you fix that? Or not? Maybe you can't fix it. Oh boy, here we go. Can you fix that T, please? Oh, it's still there. Thank you. You're the best. Or not, as it were. There it goes. Oh, okay. Wow.
I feel like you're making this worse by commentating on it. Now, cosine t over cosine squared t, you can cancel out a cosine, which gets rid of the squared, and just leaves us with cosine t on the bottom.
Yeah, and 1 plus sine t on top, and oh boy,
conveniently, that's where we were headed.
Mm-hmm.
So if you weren't paying attention to where we were trying to get, you might have been like, well, where did I go from here? But we're done.
Minecraft guy.
Prove the identity, and this example says working from both sides. Now
What's with these clues? They're not going to get clues on a test. I mean, shouldn't we, big boy pants and stuff and just dive in?
But we're teaching.
All right.
So
Just say it like that, like the children. Teach me.
Okay, so we want to basically start with one side, and we're going to see where that takes us. And basically, this is a concept of if you get stuck at one point when you're working with one side, you can try to work from the other direction, and that will help you finish your proof.
Yeah, this is not a divide both sides by cotangent u, see what factors out, work away.
Yeah,
this
is not an equation. This
work
is an
left
identity.
side, work right side.
Separately.
Separately and not at the same time.
So here, I would say there's a Pythagorean identity for cotangent squared. That cotangent squared would equal cosecant squared minus 1.
Yes.
So let's do that because on the bottom we have
Cosecant plus
a
1.
cosecant. And the only way to get those to be the same is to use the cotangent squared.
Mm-hmm.
I'm going to just rewrite this other direction just to make it a little bit prettier.
And there was no harm done in the rewriting of said equation because
it's
everything's
addition.
positive. Yes.
Yeah. So this we can factor into the difference of two squares.
Look at that. Shut the front door. That plus 1's going to go away.
Did I leave the front door open?
I don't know, but that guy just came barging right in. Look at that. Cosecant u plus 1. It's gone. It's done skis.
So cancel. So we have at the moment cosecant u minus 1. Now, it's a bit of a challenge to get from there to what's on that side.
I think let's pause the left side now. I think you're right. Yeah, working from both sides. Let's Let's head over to the right side of the equation and see what we can't simplify down over there.
All right. Okay, we're on the right side of the equation.
Okay, now I'm just going to toss out that I would suggest here to convert everything to sine cosine.
Let's do it. Cotangent is
Cosine over
sine.
sine. And the reason I say that is because if I multiply cotangent times secant, I get cotangent secant, which doesn't help me a lot.
It's not particularly helpful.
And cotangent tangent becomes 1, so that doesn't do much.
Right. Okay.
But this way, though,
we actually have a common denominator here to start off with, so we can leave the outside alone for now. Get our common denominator here. That's 1 minus, well, we have it already. So just combine these like so. Now, because we're multiplying two fractions together, the cosine u's cancel.
Look at that.
Which gives us 1 minus sine u.
Over sine u.
Over sine u. Now, there's a
trick.
trick.
Oh, I know.
Okay.
Can I say?
Yeah, go for it.
Check it out. If the numerator has an addition or subtraction sign and the denominator is just one item, then you can rewrite that guy as the first part over the denominator plus or minus the second part over the denominator.
Depending on, and you pick
Depending
the sign
on whichever
on
the sign you have, yes.
We're basically breaking up this fraction because there's only one thing in the denominator. We're allowed to do that.
The sinu.
Yeah, so 1 over sine u is how we get the cosecant
Looky there. We had to work from both sides.
Minus 1.
Independently and not at the same time.
Yes. Okay, so are we done?
Minecraft smiley face.
Okay.
Now we're done. Oh boy. Okay. Now we've got three-dimensional Minecraft smiley face. Amazing. Oh!
The whole point of these identities are
that one.
To build up some math skills perhaps, but you're really going to end up using these in calculus. Not a ton, but they do crop up pretty often.
Did you say crap up?
Crop. They crop up.
Crop. Okay.
They come up.
All right.
Every now and then.
All right.
And so basically it works out to where if you can sometimes change what you have with sine and cosine to some powers, it makes the calculus-y thing that you do easier.
Sometimes that is true.
So in this case, this would be where we were taking like some fancy word that you haven't heard yet of this on the left side, but if we could change it to what's on the right side, it'd be easier. So that's where this is like a legit, you'd use this in calculus kind of a situation.
And as a calculus teacher person, I would say that this is totally an applicable thing that we're working on here. Because there are times when you need to rewrite stuff.
Like this.
For ease of calculusing.
Yes. Notice that we have one cosine over here and all the rest of this stuff is sines. That helps us kind of figure out where to go, because if you see we've got cosine to the 5th power, well,
that's an odd number.
That's an odd number. So what we can do actually, and because of the Pythagorean identities, we can split that cosine to the 5th up into cosine squared, cosine squared.
See, that's good.
And it leaves us with that cosine.
I was thinking cosine to the 4th would have been and then cosine.
But I like splitting it up like that because now
that's genius.
We don't want to change the sine squared because there's sine squareds here.
Yeah.
But cosine squared, looking at your Pythagorean identities,
it's 1 minus sine squared.
1 minus sine squared. 1 minus sine squared. And cosine squared again is 1 minus sine squared.
Now, here's where you get to practice foiling out this puppy. And again, you need to recognize some tips and tricks to foiling out things that are identical, because it really makes life easier in the long run.
Right. There's a pattern that you do 1 squared, which is 1. There's going to be twice as much of these two terms, like
2 times 1 times sine squared x.
Yeah, so -2 sine squared x. And then
square the last term plus sine to the 4th x times cos x. I already like how this is looking.
Distribute the sine squared, and then we've got what we need. So sine squared.
So it wasn't as bad as it originally looked.
No, not at all.
Mrs. Stevenson, it's actually pretty legitimately doable.
And I don't know, like the book keeps putting these like random cosines in parentheses. You don't really necessarily
Yeah, you
need
don't
it.
need it. You don't
It
need
could
it.
have just been a cosine on
It's
the
just,
outside.
yes, that is correct.
So that's it. That's 5.2.
There you go.